Hello, my radiant students. This video is about graphing trig functions. And so today we're going to be focusing on graphing the sine function. Now, graphing the sine function, we have a general formula for it. The general formula is y equals a sine b theta. Now, the theta you're already familiar with, that means the angle. And the sine here could be the cosine, it could be the tangent. Today we're talking about the sine. The parts of this that you really need to know here are what the A means and what the B means. Of the two, let's do the A first. The A is the amplitude, and that tells us how tall the graph is. So how tall is the graph from the middle line? So you can see, this one comes up to 1, so the amplitude is 1. It also goes down to -1 from the middle. So it's like the absolute value from the middle. The amplitude is 1. Okay, and then we have this letter B here. B is going to stretch the graph, or is going to compress those waves together. Okay, and we are going to use B to find the period. Now, what does period mean? Period is how far the graph goes before it repeats. So if we follow the graph from here, we can see that it starts here, and following it goes up. Okay, it comes back to the middle. It comes down. It comes back to the middle. And then it repeats. It goes up again and back to the middle and down back to the middle. Now, how far you have to go along the graph before it starts repeating is the period. And I want to just emphasize that. Let's just take this one section of the graph. So right here I have this one piece of the graph where it goes up. I have one valley up and one valley down. That is the period. Then this piece right here, if I scooch it over, it repeats again, and the same pattern is found right here, going up and going down. And so as this pattern repeats, and it would continue to repeat if I were to move it out, this pattern continues to repeat, even going the other way. The pattern continues to repeat throughout the entire graph. So that is the period, how far it has to go before it repeats. Now, in general, the period for a sine function is 2 pi. But if you're not given the period and you want to find it, the formula for period is, for sine and for cosine, 2 pi over b. So 2 pi divided by whatever value you take from this function will tell us the period. So here's a sine wave. This example is a sine wave. Now, how I can tell it's a sine wave is because it starts at 0. A sine wave starts here in the middle at 0. Okay? We're going to see that cosine is slightly different. It doesn't start in the middle. It starts at the top. But if the wave starts in the middle, at the origin, okay, then it's a sine wave. And we can see the amplitude, I already said, is 1, and the period is 2 pi. Okay, and that is a general, what you need to know, our starting point for these sine graphs. So when you look at this, I want you to be able to say, oh, I can see the period is the number out front. I can take whatever b is and do 2 pi over b to find the period. Let's do an example. Okay, in this example, let's see if we can find the amplitude and the period from looking at this graph. And then let's see if we can write an equation for this function. So let's find the amplitude first. The amplitude tells us how tall the graph is. How high does it go up? Well, it looks like the graph is going up to about right here. So this is 1, 2, 3. So it looks like my amplitude is 3. Okay. Now I'm going to find my period. The period is how far the graph goes until it repeats. And I am going to look for the same shape of my period from before. I'm going to look for this basic shape, and I'm going to see where is this shape complete at. Okay, so I'm tracing along my graph. I see it goes up to the middle and then down to the middle, and now that's the whole shape. All right? So that is the shape. Okay, now that is the period. So it looks like I'm counting by pi's down here. Looks like I have a space and then a pi. So a half a pi, then a pi, then another space, 2 pi's, 3 pi is my period. Now I'm going to try to write an equation to go with this. In order to write the equation, I need to use my period and work backwards to find b. I know that the equation for period is 2 pi over b. The period equation is 2 pi over b. Well, if 3 pi equals 2 pi over b, then what does b equal? Well, let's see. I can cancel a pi on both sides, and then I would have 3 equals 2 over b. So I just canceled a pi. And now I'm going to multiply both sides by b. Now I have 3b equals 2 equals 2. And when I divide by 3, I can see that b equals 2/3. Okay, so I have my amplitude of 3. I have my period of 3 pi. And I was able to use my period to solve for b, which is 2/3. Now I can write my equation. The general equation for sine functions we already had. I can just plug in the a values and the b value into that. So the equation for this graph is y equals 3 sine 2/3 theta. Another example, let's see if we can sketch a cycle of the graph if we're given this information, and if we can write an equation. Well, I can see here that the amplitude of this graph is 2. So let's make a graph. And the amplitude is 2, so it needs to come up to 2 and it needs to come down to 2. The period is pi. That means that by the time it does one full cycle, it has gone pi. So if I draw one full cycle of the graph, by the time it comes back to the line, it has gone pi. Now I can kind of work backwards to fill in some spots. If that's the whole cycle, here is half the cycle, this must be half of pi, or pi over 2. Great. So I have sketched one cycle of the graph. Now let's write the equation. I know that the period equals pi. If the period equals pi, let's work backwards to find b. I know the period, which is pi, equals 2 pi over b. That's the equation for period. Let's start by multiplying both sides by b. Now I have pi times b equals 2 pi. Canceling the pi's, I can see b equals 2. So now I have my b value of 2, and I have my amplitude, which also happens to be 2. So I can write the equation by plugging into the y equals a sine b theta, and we're going to have y equals 2 sine 2 theta. Okay, this time I'm asked to sketch a cycle, but I'm given the equation. So, if I'm given this equation and I want to sketch a cycle of the graph, I have to figure out what the period and the amplitude are from the equation. Well, the amplitude is just the number in front, and the number in front is 3. Okay, and now let's try to find the period. Well, it looks like this equation here has a 1/2 that's been multiplied to the theta. So the b value here is 1/2. Okay? My period equals 2 pi over b, and b is 1/2. All right, let's simplify our fractions here by multiplying by the reciprocal. Times 2 over 1. We're going to get that the period equals 4 pi. Okay, so now we are ready to sketch our graph. We know our amplitude is 3, and we know our period is 4 pi. Okay, so let's make sure it comes up to 3. And then let's just count by pi's. Here's 1 pi, okay? And by the time we get to 4 pi, we need to have gone up, back to the middle, and down, back to the middle. If I'm going up, back to the middle, down, back to the middle, let's see. I'm thinking of my phase that I'm trying to draw, same shape. I'm going to draw in the same shape. I can see that half the shape, okay, I can see that half the shape is just the top wave, right? And the other half is the bottom U. So let's take ours. We have 4 pi. Half of it would be 2 pi. By the time we get to 2 pi, we want to have done our top wave. It needs to come all the way up to 3. And then for the second half of my phase, I'm going to do the bottom U, and it's going to come all the way down to -3. Now, you can also read information from these graphs. Okay, if I'm giving you the graph, you can use it to find the value. What is the value at 50 degrees? Well, I look along my x-axis and I find 50. Looks like I'm counting by tens, 10, 20, 30, 40, 50. Okay, I find 50, and then I come to the graph. Well, 50 is right here on the graph, and so where is that on my y-axis? It's right here. Okay, so this is, where is this on my y? This is +3. What are we counting by? 1, 2, 3. This is -2. So 50 equals -2. Here's 80 on my graph. At 80 on the graph, I'm at 0. How about -10? Where's -10 on the graph? And that's right down here. We're also at -2. Okay, so you can read information off the graph as well. And that, my friends, is the end of the sine video. Great job.